So here we've got the equation x squared plus y squared equals 25. Here in this problem we're going to find y prime, and then we're also going to find the equation of the tangent line when x is equal to 3. So here I don't particularly want to solve for y. It would make the problem, it wouldn't be too challenging, but we'd have to use the chain rule, and I don't really feel like doing that right now. So I'm just going to go ahead and use implicit differentiation, just like we've been doing all along. So we've got x squared plus y squared equals 25. Our first step would be to take the derivative of both sides of our equation. So the derivative of x squared, there I've got 2x, plus the derivative of y squared would be 2y, but again here I have to multiply by the derivative of y because I have a chain rule, so I'll have 2y times y prime. And then the derivative of 25 on that right hand side, well, 25 is a constant, so its derivative is 0. So this shouldn't be too bad to solve for y prime. I've got 2x plus 2y y prime equals 0, so let's move that 2x over. 2y y prime is equal to negative 2x, and then if I divide by 2y, that means I end up with y prime equals negative x over y if I go ahead and cancel out my 2's. So okay, that derivative wasn't too challenging to find. It wasn't too painful. My next step then would be to, okay, let's find the equation of the tangent line when x is equal to 3. Well, if I look at the equation of the tangent line, actually if I think ahead to what I need for the equation of the tangent line, I need an x value, which is always given to me. I need a y value, which in this case I don't have. And I need a slope. So if I want to find my slope, that's still going to be given to me by y prime, but in this case that y prime needs both an x and a y. So here it does actually matter a little bit what order we find these things in. In this case, I'm going to have to find y first, which means I'm going to want to go back to my original equation, x squared plus y squared equals 25. So I'm going to take the x value that was given to me and plug that into our equation. So let's see, we'll have 3 squared plus y squared is equal to 25, which means we have 9 plus y squared equals 25. So if we subtract 9, we should have y squared equals 16. And if I take the square root of this, something really weird is going to happen because I'm going to end up with y equals 4. But remember, when we solve using a square root, we end up with a positive case and a negative case. We actually end up with plus or minus 4. Now, I might be looking at this and thinking, how do I know which one to pick? And you know what? I was mistaken earlier when I wrote the directions here. It says find y prime in the equation. I should have said the equations of the tangent lines. What's cool about implicit differentiation is that we can work with things that are not functions. Now, if you were to graph this, and I have some pictures up right below this video, if you were to graph this equation, it's actually the graph of a circle. Now, I said to write the equation at x equals 3. If I said x equals 3, there's actually 2 places on my circle where x is equal to 3, one at positive 4 and one at negative 4. And since I didn't specify which one I was looking for, I'm going to have to find them both. So that means I'm going to have 2 different equations of my tangent lines. One should have a negative slope, the other should have a positive slope. So let's start with positive 4. So that would be this tangent line right here. So we said our x value was 3, and we said our y value here we're going to work with is positive 4. We'll start with that first. So I'm going to, actually real quick, grab my derivative and bring that down here. Oops. So I'm going to work with my derivative. I'm going to take my x value and my y value and plug that into y prime. So in this case, I end up with y prime is equal to negative x. That's negative 3 divided by y, which is 4. So negative 3 over 4. This is the slope of my tangent line. Now I can go ahead and write the equation of the tangent line. Oops, I'm running out of room here. We'll have to say y minus y1 is 4 equals m, that's going to be negative 3/4, times x minus my x coordinate is 3. So here I've got y minus 4 equals negative 3/4 times the quantity x minus 3. So we'll have to distribute first. So we've got y minus 4 is equal to negative 3/4 x plus, here I would have 9 over 4. And then if I add 4 to each side of my equation, I should end up with y equals negative 3 over 4x plus 25 over 4. So there is the first equation of the tangent line, and I can actually look at my graph and see if it's right. Here we have a negative slope and a positive y-intercept. Let's just double check that real quick. If I look at the tangent line here, our line is going down, so that means the slope is negative, and we intersected the y-axis above the origin, so that means we have a positive y-intercept. So there's my first equation of the tangent line. But then there's another one too, right? We also have 3 comma negative 4. We said y equals plus or minus 4. So when we have a different y value, that is going to change our derivative. So that means when we find our y prime, we're going to end up with a different slope. So we need to find a new y prime. So in this case, that would be negative x, so negative 3 over y is negative 4. I'll simplify that to be positive 3 over 4. Again, this is the slope of my tangent line. And then after that, we've got everything we need to write the equation of the tangent line. Y minus my y coordinate, negative 4, equals m, that's 3/4, times x minus my x coordinate is 3. And we can solve for y very similarly here. That left-hand side, after I simplify, really says y plus 4 equals, on the right-hand side here, I'm just going to go ahead and distribute. So here I'll have 3/4 x minus 9 over 4, and then subtract 4 from each side. I should have y equals 3/4 x minus 25 over 4 after I find my common denominator. So here's my derivative. We found that it's y prime equals negative x over y. And then in this case, I ended up with 2 equations of the tangent line. I have y equals negative 3 over 4x plus 25 over 4, and then y equals positive 3 over 4x minus 25 over 4. One thing I'll point out, it's not necessarily a guarantee that I'm always going to end up with 2 different equations of the tangent line. It just depends on at what x values does your graph exist, or at how many points at a particular x value does your graph exist. You could still only have 1. In this case, we had 2, but you could have extreme cases where you have even 3 or 4 or 5. So in most of the cases we'll be looking at, it'll just be either 1 or 2. But just keep an eye out for these types of problems where we end up with multiple y values, because that tells us we're also going to end up with multiple tangent lines.